Hello and good day in pre-algebra. We are going over the top part of CO16, the homework that we had due for today. Basically taking these values for the variables, a is 9, n is 20, x is -5, plugging them into these expressions and then evaluating. What is the result? What is the answer with these things plugged in? So it's practice with order of operations. It's practice with interpreting what different numerical math symbols mean, and obviously it's practice with negative signs and just general math operations. So the first one, 12a minus n. We substitute a for 9, or 9 for a, and we're subtracting 20. And that gives us 84. Nope, that's not right. 108 minus 20, which is 88, which is the value of 12a minus n. A plus x plus 2, substitute 9 for a. And then we run into this plus negative situation that we talked about, I think it was the third one in the second row yesterday. What does that adding a -5 mean? 9 plus -5. What is that the same as doing, Aiden? Subtracting. If you go back to P09, you might recall that adding a negative is the same as subtracting. So we can rewrite this, or think about it, as 9 minus 5 plus 2. Okay, 9 minus 5 plus 2. So that's 4 plus 2. We should get 6 as a value, 6. The next one, 3 times n divided by the root of a. So we have, I think we did this one together yesterday also, but we have 3 times n, which is 20, so 3 times 20, divided by the root of 9. Order of operations, we're going to have to multiply 3 and 20, and then take the root of 9 to get 3, and our final answer is 20. 60 divided by 3 is 20. We run into an exponent in the fourth one here. We have a squared, which is going to be 9 squared, plus 4 times 9, minus 8 times n being 20. Okay? Are a squared and 4a like terms? We talked about like terms being having the same variable, which they do. They both have an a. However, there's a second part to that we didn't talk about, just because PO15 doesn't really get into it much, but it also has to be to the same power. Same variable, same power, meaning that a squared and a, which is to the first, but we don't write the 1 there, those are actually not like terms, and that's why they are kept separate there. Okay, so 9 squared is 81, 4 times 9 is 36, and we're subtracting 160. So what is that, -45? Is that what folks got? 81 plus 36? No, -43. Does that sound better? I should do my math correctly. -43. 81 plus 36 is 117, and then 117 minus 160, -43. There you go. Second, any issues with the top row? Anything you want to talk about? Good? Okay. Second row, 3a plus 2a. Those are like terms, right? And so we could either take 3 times 9 plus 2 times 9, which is 27 plus 18 to get 45. Or if you wanted to, you could just combine those to get 5a and just take 5 times 9, which is also 45, right? Because 3 9s plus 2 9s is the same as 5 9s. That's why they're like terms. That's why they can be combined, and that's why we'll get the same answer here. Okay? Remember we talked about in PO15 as far as checking your answers, that if you plug in a variable to the original expression and then plug in that same value into your new expression, you'll get the same result because they're equivalent expressions. Their values are the same. So 45 is the story for that one. The next one, 2 times n plus 6. N is 20. So we have 2 times 20 plus 6 plus 10 times negative 5. Order of operations in our parentheses, we get 26, which we're doubling. So that gives us 52, 26 times 2. And then 10 times negative 5 is a negative 50. So again, we run into that adding a negative situation, which is the same thing as subtracting. So 52 plus negative 50, or 52 minus 50, you should get positive 2 as an answer. Positive 2. The next one we did together, we've got 150 minus 2 times 20 plus negative 5. Again, that adding a negative piece. So in our parentheses, we really have 15, right? 20 plus negative 5, 20 minus 5. Order of operations, we would multiply 2 and 15 first. So we have 150 minus 30, and that gives us 120. So double check that you didn't subtract 150 and 2 to get 148 and then multiply that by 15. So if your answer for this one is really, really big, then that's what you probably did. You subtracted before multiplying. We do need to multiply 2 and 15 first. Okay. Then the last one, negative 5n, the root of 5n, not negative, the root of 5n plus 3x squared. So we have the root of 5 times 20, using the dot there to show that we're multiplying, plus 3 times negative 5 squared. So in our root there, 5 times 20 is 100, which is a perfect square. It simplifies down to be 10. So how you handle that square root is you'd multiply within the root. 5 times 20 is 100. Then take that root, perfect square, to get down to 10. And the reason why I put negative 5 over here in parentheses is that if we're squaring, and this is why I do circle it, because it's kind of coordinates here. If we're squaring a negative number, x squared, if that x value is negative, it means that we're taking negative 5 times negative 5, which is what? Not negative 25. A negative times a negative is a positive, right? So whenever you square something, it's always going to end up being a positive value, because either you're taking a positive times a positive, or you're taking a negative times a negative, both of which will end up being positive. If you did this in a calculator and you put negative 5 squared in your calculator, you would get negative 25, because you didn't include parentheses. Your calculator always does the correct order of operations. If you put this in your calculator, you're telling it to square 5, which is 25, and then make that negative. So when you square a negative number, putting parentheses around it in your calculator is required. Yes, Aiden?
Your negative's far from the 5, so I thought it was 5 times negative 5.
My negative is what? Sorry?
It's a little bit farther from the 5.
Right here?
Yeah. So I just looked at the 5 and that times negative 5.
My apologies. My apologies. Millimeters make a difference. Okay. So in any case, negative 5 squared is positive 25. We're multiplying that 25 by 3. And so we get 10 plus 75, and that equals 85. 85 is the value of that last one. Okay. All right. Any questions, comments, concerns, complaints, compliments, congratulations, or criticisms on that? May I take down the notes? Okay. Let's go on to the coordinate plane kind of graphing sections down below here. It says, write each situation as an expression, evaluate it for the given values, and then graph it. So kind of what we've been doing, I want to minimize this, I'll make it a little bit smaller here. What we did in the top section here, we're going to be doing here. We're going to have an expression with a variable. We're going to be evaluating it by plugging things in. The additional thing now is that we are going to be writing the expression ourselves and then graphing it on the coordinate plane here. Your experience with plotting points on the coordinate plane. Thumbs up. We've heard of the x-axis and the y-axis. Which one is the x-axis? Horizontal or vertical? Horizontal, okay. And the y-axis is the vertical, all right? So if you are, need a reminder, you can label this x and label this y, okay? That might be helpful. An ordered pair is always written in what form? In what order? Thus the ordered pair. What order is it, Aiden?
X first and Y.
Yes, okay. An ordered pair is always written in x, y form. So you always look to the x-axis first and then the y-axis. Of course, this is just part of the coordinate plane, right? This is just the top right quadrant. The coordinate plane really extends forever downward and forever over. But given the data that we have today, we're just going to be talking about that top right section. So in any event, here we go. You want to save up to buy an iPhone and decide to put $3 each day into savings. It's going to take you a while. How much will you have saved on day 5? How about day 8? How about day 12? Okay, so what we want to write here is we want to write an expression that represents the total amount of money you have in savings on any given day. So what expression is going to tell you that? What expression is going to tell you the total amount that you have saved up on any given day? Ifan? 3 times 5 would tell you how much you'd have on day 5, right? What would you do to figure out day 7? Multiply 3 times 7, right? How about day 10? 3 times 10. How about day 12? 3 times 12. So what expression will tell us how much money we have saved up on any given day? Connor? A number times 3, and we're going to represent that number using the d variable, right? If we set d equal to the number of the day, like Ifan started saying, on day 5, just multiply 3 times 5. On day 7, multiply 3 times 7. On day 10, multiply 3 times 10. On day 12, multiply 3 times 12, right? Whatever the number of the day is, we're going to multiply that by 3, and that's going to give us our total savings. So the expression that represents this is 3D. Okay? So we can make a little chart for the day and the savings. If our expression is total savings equals 3D on day 5, what's our total savings? Ifan, I'll let you take this one because you kind of brought it up first. On day 5, how much have we saved? 15, right? 3 times 5 equals $15 saved. I also ask you for day 8. On day 8, how much money will you have saved? Connor? 24. We got that by taking 3 times 8, right? Replace 8 with our variable for the 8th day and multiply that by 3. How about day 12? How about day 12? Maggie? 36, right? 3 times 12 equals 36. Okay? So this is what pre-algebra and algebra are going to allow us to do. We have an expression that gives us some information, and we are able to predict what's going to happen in the future. You know, if you want to get this iPhone within the next month, is $3 a day going to cut it for you? Oh, day 12, we're only at $36, right? So that information, you predicting this and looking at this and analyzing it, might allow you to decide, I might want to put more than $3 away every day, right? So graphing this now, okay, our ordered pairs, well, first of all, which column in my table do you think is my x variable and which column is my y variable? Aiden?
X is day and Y is savings.
Right. X is day and Y is savings. Okay. You can think of your X and Y variables as input and output, right? Or the value that we're plugging in and the answer, right? So that's kind of how our equations are going to be set up for the time being here. So we're going to graph this out to day 12. I've left this blank here because we get to kind of decide how we're going to label it. Okay. If I go out, let's see, how many? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 89. Well, that's inconvenient. So I'm going to make every line here just one unit. So I'm writing the numbers 1 through 12 down across the bottom here. I thought about going every other, but I only have 20 X marks there, and I have to go to 24 if I count it by 2, so I'm going to come a little bit short. So I'm just going 1 for every one out to 12. And then what should I count my Y-axis as? Should I go by 1s?
No.
Should I go by 2s? Should I go by 3s, by 5s? What do you think? We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20 going up. So if I count by 1s, I can already see that on day 12, I've got $36. I've got to have more than that. Should I count by 2s? That would probably make some sense, right? It would be actually, you can make an argument for either 2 or 3, right? If I count by 2s, that'll make my maximum Y value 40, which means I'm going to use, a large part of the graph. We don't want all of our data just kind of scrunched down here at the bottom, right? But if I count by 2s, I'm using most of the graph. However, counting by 3s is going to make my plotting a lot easier because this is going to be increasing by 3 every time, right? So I think we should count by 3s. I kind of like that idea. So 3, 6, 9, 12, 15, 18, 21, 24, 27, 30, 33, 36. You probably don't need me to count. And we should get all the way up to 60. Going up the side there. Counting by 3s. And we're going to plot each of these pairs, which my first one, 5, 15, right? On day 5, I have $15. That's my first ordered pair. So 5, 15 is going to go right here, right? The intersection of 5 on the x-axis and 15 on the y-axis. Then my next one, on day 8, I've saved $24. So the order pair is 8, 24. Find my line for 8, 24 right here. There we have it. And then my third order pair that I have in my little table here is 1236. On day 12, we're saving $36. So go to the end of my x-axis here, up to 36, and there we have it. Okay? Now, what shape or what figure do our 3 points make if I were to connect them? Do they make a circle? Do they make like a dog type figure? What do they make? They make a line, okay? And what we're dealing with here are called linear functions. And you think about that word linear, that means line. Your graphs for these should all be lines because we're increasing at a constant rate, right? Every day is just up 3, up 3, up 3, up 3. It's not like we go up 2 one day and up 5 the next day, then we spend some, so down 1 the next day, and then up 10. Okay, that would be all over the place, but that constant rate is going to give us this straight line here. So if I ask you, oh, I thought that was like someone's computer or something. Like, oh my gosh. If I ask you, how much will you have saved on day 15? You could either use the equation and multiply 3 times 15, or you could continue this line going up, right? We look at this pattern, right? It's kind of going, I'm really bad at drawing straight lines. I was absent today in kindergarten when we went over connecting the dots. And so I'm really horrible at it. But on day 15, where is this line going to intersect? Right close to there, which is 45. Who's scooting their chair? Why? Just get it done with. Give it one big shove. Thank you. I'd rather have that than little. Okay. So anyway, so on day 15, we have $45 saved, and the two ways we can see that are either using the graph. That's why we make it. That's the value of it, right? Or we can use that expression that we wrote back over here. Okay. But representing something either with an expression or an equation or graphically, okay, they both have their advantages. Questions on this thus far? Okay, let's go on to the next page then. It says, how many do I have here for you? Do I have 3 of them? I have 3 of them, yeah. So the next one says, your parents give you and your sister points for each chore completed, and today, in the spirit of Christmas, they're going to double the total points earned. Before doubling, your sister earned 7 points. How many total points will the two of you have together if you earn 3 points, again, before it's doubled, or 10 points or 15 points? Yowza. Okay? So what's happening here is your sister already has 7 points. Is that going to change? No, that's done, right? So is that going to be the variable? No. The doubling. What does it mean to double something? We talked about this when we talked about writing expressions. What does it mean to double something? John? Multiply by 2. Okay, so we're going to be multiplying something by 2. What changes here is how many total points you are earning. Okay, so what variable do you want to use? For that? Probably p. That would probably make sense. P for points. So what we're doing here is we are adding your sister's points to however many points you are going to earn. So we have your points, p plus 7, and then we're doubling that. How do we show that we're doubling that sum? Add a times 2. Well, if I only add a times 2, what am I multiplying by 2 here? What am I doubling? P plus 7 or just 7? Not the way it's written, right? The way it's written here, I've got to multiply 7 and 2 before I add P. Okay? If I want to show that I want to multiply P plus 7, those at home can't see my hands right now, but if I want to show that I'm multiplying P plus 7, Aiden? Parentheses, yes. In this one, parentheses are necessary because we are doubling the total points that you and your sister earn. Okay? So 2 times P plus 7. So if we make our table here, let's say we'll call it your points. And total points. Okay? It says, how many total points will the two of you have if you earn 3 points? If you earn 3 points, how many total points will there be in all? Pierce? 10, but then you have to double it.
20.
So 20, right? The expression that you would use here, 2 times 3 plus 7, which is your points being 3, or 2 times 10, 20 points in all. How about if you earn 10 points? How many total points will there be? This time, instead of 3 plus 7, now we have 10 plus 7. Everything else stays the same. Your sister earned 7 points. That's not going to change. Your point totals are being doubled. That's not going to change. What changed is how many points that you earned. What's our total? Sorry?
70.
It's not 70.
17.
17, but then we have to double that. So 17 times 2?
37.
Not 37.
25.
Nope, not 35. 34. Okay. Add that 10 and 7 to get 17, but then you have to double that to get to 34. And how about if you are super productive and earn 15 points? So again, the only thing that changes in our expression is the variable, not the 7, not the times 2, just how many points you earned. How many total points have been earned here? Ifan? 44. 15 plus 7 is 22. That gets doubled, and we get 44. Okay. Which column here is our x and which column is our y? Which is our input, which is the x, which is the output, which is the y? What's being tested? That's the x. What's the answer? That's the y. 3 different ways all to say the same thing. Aiden?
X is your points, and the Y is total points.
Yes. Okay. X is your points, y is total points. So the ordered pair that we get for 3 is 320. Your points 3, total points 20. The ordered pair that we get for 10 is 1034. Your points 10, total points 34. And the ordered pair that we get for 15 is 1544. Your points 15, total points 44. For tomorrow, I would like you to just graph this situation on the coordinate plane here. So you need to decide, what are you going to count up by? Are you going to put your x-axis by ones, or by twos, or by threes? What's going to make the data best fit? And then knowing that your maximum y value is 44, how are you going to divide your y-axis? By ones, by twos, by threes, or whatever. I need to be able to see what you decide. Okay? So if you come tomorrow and all you have are 3 dots somewhere on your coordinate plane, you didn't graph it correctly. I need to see the data, what you're counting by, your intervals. Okay? And remember, your 3 points should make a line. Okay? They should make a line. All right, so homework tomorrow, just this one. We'll go over the bottom one in class tomorrow. That, folks, is how you math.